this video we'll talk about the ANOVA test. ANOVA test is basically the extension of the t-test. As we have studied already about the t-test. T-test is nothing. The statistical test where we try to check the means of the two samples. Right. In a t statistics where we try to check the significance difference in the means of the two samples that made by the assumptions. Right. ANOVA test is the extension of the t-test. And ANOVA test, when we have more than three samples, right, and if you want to check their means, either there is a significant difference or not, we use the ANOVA test. Right. ANOVA is nothing but the statistical test, or I can say the extension of the t-test, where we used, if we have three or more than three samples and if you want to check their means, we will use the ANOVA test. Now there are two types of ANOVA. One is the ANOVA, second is the two-way ANOVA. Right. And ANOVA test will try to study with the one factor. Right. What is the one factor? I will tell you in a while. And then in next video we will discuss about the two-way ANOVA. So let's discuss first the what is ANOVA. Right. So let's discuss the one-way ANOVA. So what is the ANOVA? Let's suppose it is nothing but the analysis of a variance. Right. We check the means, samples mean, with the analysis of the variations. What kind of variations happens, right? We study the variations. So this is the samples I have: sample 1, sample 2, sample 3. Right. This numbers representing the students' marks. Right. Student marks. Now we want to see. Here is the assumptions that average marks of this sample 1, which is the class A, average marks of the class B, and average marks of the class C are equal. Right. When there is a one factor, which is a one factor? One factor is that is the class model. For each class, different model is applied. Right. What is the assumption is saying? Null hypothesis saying if for each class different model is applying, is there any variations in the marks or not? So assumption is saying there is no. The null hypothesis is saying there is no difference in the means or in the average of the marks of the students, right? Even though there is apply the different models. Right. If you can see the student of the marks, we can see these marks of the students. Right. These students take the online class model. Class A take the online class model. Class B take the physical class, and class C take the hybrid means physical online both. Right. So a null hypothesis is saying if there is even though there is a one factor that which is the model different model classes, there is no variation in the student marks. Right. In the student marks, there is no variation in the students marks, the average of the student marks, even though there is applied the different model, which is the one factor only. Which is the factor is the model class model, I can say that for each class, for each sample, the different model is applied. Right. Still the null hypothesis saying there is no difference in the average marks of the students. Right. Now the alternative hypothesis is saying there is a difference and the average marks of the class A, the average marks of the class B, and the average marks of class C when the model is applied. If the online class is applied, if the if it if the class A takes the online class, if the class B takes the physical class, and if class C takes the hybrid class, there will be the variation in the average of the student marks. This is what the alternative hypothesis is saying. There is a no equality, or I can say no equal marks of the students. Now how can we prove this? Either the null hypothesis is supported or rejected. How can I support or reject the null hypothesis? There is no variation in the student marks with the help of F test. Right, with the help of F test we will be able to support or reject the null hypothesis. How can we calculate this F test? With the help of this table. And now see this x1, x2 and x3 are nothing. X1, x2, x3 are nothing but the samples. Class A is the x1, class B is the x2, class C is the x3. Right, these are the values of the class A, these are the values of the class B, and these are the values of the class C. And this x1 square, x2 square, x3 square is nothing but the, if we take the square of the values of the each sample, we take the square of the this value, we take the square of this values, we take the square of this value. It is nothing. Right, here is the total. Right, and what is this? What is the summation of x square ij? It is nothing but the summation of x1 square, x2 square, x3 square, right, by rows. If we do the summations of the x1 square value, the x2 square value, the x3 square values by row, we will get this value. Right, similarly for each row we will do the summation. Right, and if we then in the final, if we add this, we'll get this value 36739. Right, this is nothing but the square x, summation of x square is nothing but this squared of these values, and then we do the summation by row, and in the end, if we sum of all the values, we will get this value. What is the tj? Listen, tj is nothing when we do the summation of the x values, mean the sample values. We will do the summation of this sample by column, we will get the 251, 215. And if we do the summation of the x2 with the sample 2, we will get the 251. If we do the summation of x3 values by column, we will get the 185. If we do the total, we get the 651, and this is 651. And tj square is nothing but the, once we do the summation of these values, we will get this value, and then we do the square of these values, and this is nothing but the square of these values, and then we do the summation, we will get this value. Right, now what is the x summation of x square? If you can see here, these both look similar, but the difference is this is done the summation by rows. Right, summation of x1, x2, x3 by rows. We do the summation of these values, x1, x2, x3 values by rows. If we do the summation of this x1 square by column, we'll get this. If we do the summation of this x2 square by column, we will get this. Similarly for the x3, we will get this, and then if we do the summation, we will get the similar value what we get here when we did with the summation by row values. This is the table we have got. Right, now what is the correction factor? Correction factor is nothing. If we do the square of this total, tj total, and divide it with the 12. What is the 12? 12 is nothing but the total values of the sample. If you can see there, 1 2 3 1 2 3 4 4 multiplied by 3, their total are 12. This is nothing but the 12 values of the total sample. If we divide this, we will get this value. Now what is the TSS? Now what is the TSS? Listen, we are using the ANOVA test. ANOVA test means we are doing the analysis of the variation. With the help of this technique, we will be able to do the validate the assumption or not, right? So analysis of variance, there are types of the variation we see in this table, right? The TSS is nothing but the total sum of square. Now what is the total sum of square? If you can see here, this is the formula of the variance, summation of x bar whole square divided by n minus 1, right? This is the unbiased estimator. If you can see here, this is the variance formula. This is the variance formula, which is the summation of x minus x bar whole square divided by n minus 1. This is the variance, or I can say unbiased estimated, because we are dividing with the n minus 1, right? So this is the variance formula, and this is the sum of square. Right? Sum of square is nothing but the summation of x minus x bar whole square, right? This is the term sum of square is very used. You will hear this word sum of square in this ANOVA. Right? What is basically the difference between the sum of square and the variance? If you can see here, right? So in a variance, if you can see here, in the variance, we are there is the n minus 1 in the denominator, right? So if we divide with the n minus 1, it is basically, variance is nothing but basically the average of those data who are spread from the mean. Variance is basically the average of those data who are spread from the mean, from the center. That is what the variance, right? Variance is nothing but the average of those data who deviate from the center, from the mean. This is what the variance, right? What is the sum of square? Sum of square is not an average of the spread of the data. Sum of square is basically the summation of x minus x bar. This is basically the summation only, right? We are not interested in n minus 1 average of the spread of the data. We are only interested in a summation of x minus x bar whole square. This is the sum of square, right? That is the difference between the variance and the sum of squares. Reason why we use the sum of squares in ANOVA, and because it is very useful. Total sum of square means total variation in this. How will you calculate the total sum of square? With the help of this formula, double summation of x square ij. This is nothing but this value, right? It is nothing but this value. If we divide this with the correction factor, we will get this value, which is nothing but the total sum of square. And total sum of square means the variation happened in the total values. What is the BSS? BSS is nothing but the between sum of square. You will get this with the help of TJ squared, which is nothing but the square of these values, right? Square of this value, which is nothing but the total 143451. And when we divide this by 4, why we divide with the 4? If you can see here, if we want to calculate the between sum of square, we'll divide the TJ square with the R. R is nothing here is the 4. What is the 4 here? If you can see there, in each sample, how many values are? There are 4 values, 1 2 3 4, right? For each sample there are 4 values, so we will divide with the 4, we'll get this value. Now so far we have calculated tj square, ex square, and with the help of this we will get the correction factor and the total sum of square and the between sum of square. Now between, as I say, that sum of square is nothing but the variation, right? So here we found TSS and BSS. TSS means the total sum of square and BSS means the between sum of square. What does it mean by between sum of square? Listen, between sum of square means we want to see the variations in this table. We want to see the variation of the student marks between the classes, right? If you are taking the online classes, if they are taking class B are taking the physical classes, if they are taking the hybrid classes, we want to see the variations between the samples between the class A, class B, class C, and this is known as the between sum of square. Between sum of square means if we want to see the variation between the samples, where the samples are, you can see the class A, class B, and class C, right? So this is known as the between the samples. Now we have calculated the total sum of square, between sum of square. There is one more thing which is known as the within sum of squares. So basically in ANOVA, in a single ANOVA, in a one-way ANOVA, I can say one-way ANOVA means there the only one factor is involved, right? With the, so in a one-way ANOVA, or I can say in ANOVA, there are two types of variations. First, as I've already told you, the variation we want to see here between the samples. Here we want to see the variations between the classes. How many variations happen in the student marks between the classes. What is the other type of the variation? Other type of variations is what is the variation happened among the classmates, within a samples. What are the variations happen among the classmates, or I can say the samples, sum of squares within a samples, means for each sample how many variation happen among the classmates, right? This is known as a within a some sample, and this is known as sum of square within a samples, right? This is known as sum of square within a sample. Within a sample means we want to see the variations among the classmates, how many variation happened among the students of the class A. What is the variation among the students of the class B? What is the variations among the students of class C? Now this is known as a sum of square within a samples, right? Or I can say the sum of square within a group. So there are two types of, one is the variation between the samples and one is the variation within a samples. And once we get these two variations, then we will move forward, right? Once we calculate the within a sum of square within a sample, which is nothing but the 2 at 7 6 to 5, right? Now we will find the degree of freedom of between samples, sum of square between samples. How will find the degree of freedom of sum of square between the sample? With the help of this formula, k minus 1. How many samples are there? There are 3 samples. We'll minus 3 minus 1, we'll calculate the 2. Now we'll find the degree of freedom of the within a sample, sum of square within a sample. How will find this 9? How many values are in a samples? Total value, there were 12 values. How many samples are there? There are 3 samples. If we do minus 12 total values minus total samples, we will calculate the 3. This is nothing but the 9, right? Similarly, if we see the total degree of freedom, there are 11, right? We have calculated already sum of squares. Now we will calculate the mean of square. How can we calculate the mean of square? We similarly divide the mean of square between the sample. How can we calculate the mean of square between the sample? We will divide degree of freedom 2 with this value. We will calculate the mean of square between the sample, which is nothing but 273. If we want to calculate the mean of square within a sample, we will divide the degree of freedom of the within a sample with this value. We'll calculate the mean of square 973. Once we calculate the mean of square between the sample, mean of square within a sample, now it is easy to calculate the f test. We will just divide this value within a sample mean of square with this between the mean of square between the sample value, and we divide this value with this. We'll calculate the f test, f ratio. This is the f ratio. Now with the help of this f ratio, we will calculate the p value, right? If the f value is very high, the p value will be very value. P value is nothing but the probability of this f value where the null hypothesis is true, right? If the p value is very high, means p value is greater than alpha, we will support this null hypothesis. If the p value is greater than alpha, we will support this null hypothesis, and we are able to say there is no variations, there is no difference in the mean of the class A, class B and the class C marks, right? If the p value is less than alpha, and once we calculate the f test, we will calculate the p value. If the p value is greater than alpha, which is 0.05, we will support the null hypothesis. Null hypothesis saying means the average marks of the class A, the average class of mark B, the average marks of the class C are equal. There is no difference in the average marks of the class A, class B, class C. Taking into consideration there is the one factor that for each class there was a different model. Even though there was a different model for each class, still there was no variation in the student marks. So that is how we supported this assumption, that there is no variation in the student marks even though there is a different class models. So means this class model does not affect the student marks, and there is no relation between the class models and the student marks. So that is what the null hypothesis is saying. So if the p value is greater than alpha, we will support this. We are able to say that there is no if the null hypothesis is true, we are able to say that there is no difference in the student marks, right? Even though there is a different models. That is all about today's video. Right. And ANOVA test is used to check the means of the samples, if there are samples 3 or more than 3 samples, right? If there are 2 samples and we want to check their means, we will use the t-test, right? But if there are 3 samples or more than 3 samples, we use the ANOVA test. ANOVA test is basically the extensions of a t-test, nothing else, right? This is the basic thing I can say there. ANOVA test is basically the extension of the t-test where we use more samples, 3 or more samples. That's why we use the ANOVA test, where we do the analysis of the variations, how many variations between the samples, how many variation within the samples. The reason why it is known as the analysis of variance, because we are doing the analysis of the variations, right? That is why we use the ANOVA, right? This is all about this video.